Good afternoon and welcome to another insightful webinar from Secure Intelligence Limited. My name is Iyenu Ukonga, and today we're going to be discussing achieving high performance workloads through AWS well-architected design. And our host today or our speaker today is Oluwabamiche Ojo. He is a cloud engineer here at Secure Intelligence Limited. Please note that as we go forward, we have a few housekeeping rules that we have to adhere to in order to help us have a smooth webinar. Please note that this webinar is being recorded and will be put on all our social media platforms. And just in case you have any reason to get up during the webinar, note that you can go on all our social media platforms, including our YouTube channels, and you will find a pre-recording of this webinar. Also, note that you can raise your hands if you have any.
It seems our host is having a kind of network glitch. Thank you so much for joining us. Please, can you move to the next slide while I fill in for her for why she gets back our network? So thank you. Welcome to Achieving High Performance Workload through AWS well-architected design. And she was trying to talk about some housekeeping rules that we should be aware of. Please, next slide. Please, next slide. And part of the housekeeping rules is that you can raise your hands, but you are currently in listen-only mode, which means that you can't speak for now unless the speaker wants you to speak. But you can use the Q&A to ask questions and also to seek any clarifications that you want. And also, please be aware that this webinar is being recorded, right? What it means is that we are going to put this on our social media channels, and you can always get the recording immediately it is available. Okay.
Thank you very
next
much,
slide, please.
Emeka.
Queen, are you back?
Yes. I'm sorry for the network interfering with what I was trying to say. Please note that there will be a calendar link in the question and answer section. So if you need to book a consultation meeting with any of the sales development representatives on our team, you can click on that calendar link and it will take you to a calendar where you can book a consultation meeting. I'm going to be handing this over to our presenter for the day, Oluwabamiche Ojo. He takes you on the journey of achieving high performance workloads through AWS well-architected.
All right. Thanks for the warm introduction, Queen. So my name is Oluwabamiche Ojo. I'm a cloud and machine learning engineer from Secure Intelligence Limited. So before we talk about our webinar now, before we dive in, I'll be talking about the agenda of the webinar. So firstly, I will talk about briefly about the AWS well-architected framework and its 6 pillars. Then we talk about the performance efficiency pillar in details and the design principle, best practices to use while implementing your architecture and workload in the cloud. Then also we talk about serverless briefly, then how to optimize performance of your workload, making use of AWS X-Ray. Now to the overview of the 6 pillars and AWS well-architected framework. So AWS well-architected framework is a set of practices and best practices and design principles that help you to measure your workload and architecture against best practices. So this help you to know the implication of the decision you make in cloud. For example, if you decide to go with one particular architecture against another, to help you to know what you are into, the implication of selecting one and not using this. And for the well-architected framework, we have 6 pillars. we have operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Sustainability is talking about minimizing the environmental impact of your workload, and why the cost optimization is about avoiding unwanted costs. For example, you could have an underutilized EC2 instance running in the cloud. So you don't want to waste cost on this type of computing option if you have underutilized or underused EC2 instance in the cloud. For performance efficiency, we'll be talking about that deeply later. While for reliability is about how quickly can your workload recover from failure. While security is about protecting your workload from threat and unauthorized access. For operational excellence, this pillar is talking about managing and monitoring your production workload to deliver your business value requirements and even to continuously improve this your business value or workload if there's a need to improve on it. So now to performance efficiency. Performance efficiency focus on the efficient use of computing resources. So for performance efficiency, you need to make use of the right tools for the job. This is what this is talking about. So in order to meet your requirements, if you decide to not use the right tool for the job, that will not help you to meet your requirement. And also, this is not a one-time thing. You have to continually review your decision, the type of architecture you decide to use, the type of database you decide to use. You need to continually monitor and review it to check the efficiency, how efficient they are in the cloud. So before we go further, I will try and talk briefly about the design principle and best practices. So for best practices, this is like a detailed implementation step to follow to have a high performance workload in cloud. While design principle is more of a philosophy or guidelines or an overview of a guidelines to follow. So this will help the best practices will help us to be more practical. So for the best practices, they are divided into 5 focus areas. So we'll be talking about them later. So for design principle, we have the first one, democratize advanced technology. So for example, we have some advanced technology now, for example, machine learning, that normally we require specialized expertise before we could use them in the past. But now you can consume them in the cloud as a service. For example, we have different AWS machine learning services. We have Transcribe, AWS Transcribe, we have Comprehend. So initially, you have to come up with a model. You need to train your model before you could come up with something like that before. But with the advent of cloud, you could consume all these services from the cloud. So you can democratize this advanced technology and make them easily available for your team. So you are dedicating this complex task to your cloud vendors like AWS now. So you can also go global in minutes. So you can be in Nigeria and deploy your workload to other regions because AWS have different regions in the world. We have US, we have regions in the US, in London. So for example, if you have a client or customer that makes use of your application in all these other parts of the world, so you could deploy your workload in those regions. So you also can use serverless architecture when the need arises for it. So you need to understand the requirement of your workload before you decide what to go for. So, but for making use of serverless, quite advantageous now. So it removes the need to run and maintain servers. So that means you are giving the maintenance of the servers to your cloud service provider. And also, the next design principle is about experimenting more. So before you could understand the different options available, you need to explore the different services, different cloud services in the cloud. And the last one here is talking about mechanical sympathy. So this is about making use of the right tools for the job. Now we'll be talking about the best practices. So like I mentioned earlier, the best practices are broken down under 5 focus area. So we have these 5 focus area are architecture selection, we have compute and hardware, we have data management, we have network and content delivery, and we have process and culture. So for architecture selection, before you could decide on the type of architecture to use for your workload, there are some best practice and implementation steps to consider. The first one I'm talking about is to use a policy and reference architecture. So you could have internal policy that guides your decision, maybe the type of architecture to use for particular workload. So you can start from there, check your internal policy. You can also reference external policy to know the best architecture to use. Then the next one I will be talking about is learn about and understand available cloud service. So the experimentation comes in again. So it's quite very important to experiment often. For example, AWS release updates regularly for their services and new products. So you need to explore and experiment to know the available options that are available. And also to experiment, you will be making use of non-production environments. We'll be talking about environments, different software development environment later in the webinar. But for experimentation, you will be making use of sandbox, which is a non-production environment, because normally you want to reduce the number of people that have access to your production environment. And also use guidance from your cloud providers. So that's another best practices. So your cloud provider like AWS, we have different guidance or documentation to follow. So documentation is always the best first place to look into when you are looking into a new service for the first time. And also there are different training platform provided by AWS. We have AWS Start, we have AWS Kibida. So you could look into all these platform and documentation to learn more about this cloud service and architecture type. So next we'll be talking about compute and hardware best practices. So I think I will keep overemphasizing on the importance of experimentation. So in order to know the best compute option available for you, you need to experiment again. So experimentation, and also while doing the experimentation, we understand the different compute configuration and features that are available. For example, now we have for EC2 instance, there are different type of EC2 instance. So for where you are supposed to use a T2 micro instance, maybe you are just trying to carry out a POC, you are now using a nano size. So that means you are not making use of the right compute option, because that will be that will incur cost more than the T2 micro. So also you need to collect metrics for your compute related workload. So this will help you to understand the performance of your workload over time and help you to know where you need to make improvements. And also you have to configure and right size compute resources. I think I talked about this briefly earlier. So next I'll be talking about data management best practices. So you need to use a purpose-built data store. So for, let's say for instance, for S3 now, we have different S3, that is a storage service for object storage for AWS. For S3, we have different type of storage. We have the standard, we have the archive. So for the standard, that means you'll be frequently accessing your data. For the archive, you won't be accessing your data frequently. So if you use archive where you are supposed to use standards, so that will affect the performance and even cost now of your workload generally. So you need to understand the data access pattern of your workload. And the next one is talking about configuration also. So we talk about that earlier on. For the configuration of data management best practice now, we have for S3, we have lifecycle management. So you could define a policy that will help you to move your data after some particular period of time from the standard storage type to the archive month, maybe you won't be needing that data after 3 or 6 months. So you can just define this policy. So this is one of the best practices to follow. And the next one is also talking about metrics. It's quite important to get metrics for your workload and data in the cloud. Then to improve the data query, to improve query also, the performance of your query, you need to define some strategies. So for example, now you can decide to make use of a columnar file format. For this columnar file format, we have a packet and ORC. So ORC is optimizing a raw format. So this type of format, they work easily with compression of data. So if, for example, if data storage space is a concern for you, if you are working with a large data set, so you could compress your data, you could make use of partitioning. So these are strategies to improve the query performance. So also we have, okay, I think I mentioned compression already. Then we could make use of caching also. So caching is now like an in-memory database type. So we have Elastic Cache for AWS, which is a type of caching. So this will reduce the workload on your database, for example, DynamoDB. So for your DynamoDB, for example, maybe there's a frequent read access to your DynamoDB. So if you make use of Elastic Cache, it will reduce the workload on your database, like I mentioned earlier. So moving forward, I will be talking about networking and content delivery best practices. So for networking and content delivery, firstly, before you decide to go for a particular option for your networking, you need to understand the requirements. You need to define the requirements. You need to document them for reference purposes. And we have different type of networking and content delivery option. For content delivery, we have different load balancer. We have a network load balancer. So for network load balancer, you'll be making use of network load balancer for UDP protocol. For example, there are some applications that make use of UDP protocol, like video streaming, live streaming, video conferencing, and call. So all this type of application makes use of UDP protocol, and they make use of network load balancer. We make this the distribution of this traffic to be performance. So if you decide to use application load balancer in place of network load balancer in this place, the performance of the application will be affected. And also we have direct connect. This is a networking option. We have side-to-side VPN. So you need, based on your use case, you need to know when to use this type of networking option. So this still comes down to experimentation and your own personal research. And we can decide to take the burden away from you and your team. We can outsource this type of work to AWS partner like us at Secure Intelligence Limited, because we have a dedicated team to handle this and even to handle the well-architected framework review. So next, I'll be talking about the process and culture. So this is one of the, will I say, something that is in vogue now, process and culture. It's talking about more of DevOps now, deployment strategies, CI/CD, infrastructure as code, and the likes. So for infrastructure as code, which is IAC, for AWS, we have a cloud formation. So it's the best practice to make use of this type of practice while deploying your infrastructure in the cloud. So for example, you could have like lot of servers you are managing that is supporting a particular critical workload. So instead of going to your management, AWS management console every time you need to run an update or patches, or you need to change some configuration, so you can make use of infrastructure as code. So that will reduce the any error that could happen, because normally if you are going to the console, human beings are quite prone to error. But if you have infrastructure as code and be automated tests in place, which is also similar with deployment pipeline, the CI/CD. So with this, it will check every of your deployment to make sure they are in conformance with the stated test and checkmate that you have put in place. For load generation, this is more about you generating synthetic traffic to test your workload to know where it will break. So once you know the level at which your workload can break, so you can improve on that. So for this load generation, you can make use of something called a game day or chaos engineering. So this is like you stimulating chaos itself before someone else stimulates it for you. And for deployment pipeline, yeah, you need to have this best practices talking about having different environments and CI/CD in place. And this is quite important because if you have different environments, firstly, it will save you from having a single point of failure. For example, you have development environment, you have test environment, and production environment. So your developer usually will start from the development environment. Once work is done in that environment, you push that change to test environment. There will be people, someone like a quality analyst that will test the new release to make sure they are doing the right thing they are supposed to do. Once the new features pass that test, it can now move to production environment. So these are a lot of benefits. It also secure your workload because if you are using one environment, if someone, an authorized person have access to that environment, it could sabotage all your workload and application. But with just one, with three environment now, even if there's an unauthorized access to one of the environment, you still have two other environments to fall back to. So for performance, feasibility, and visualization, so this where services like AWS CloudWatch and X-Ray, which we'll be talking about later, comes in. So they help you to collect metrics, log, and traces to help you to monitor the performance of your workload and to know where you can improve on. So next slide will be, this here is talking about the best practices in detail. So I've mentioned most of them in the previous slide. So here we're talking about process to improve workload performance, load test like I defined earlier. And also you need to put some, let me add this, you need to put some process in place for remediation. Maybe there is an incident and you want to fix it. So you could have playbook or run book. So they will list step-by-step procedure to follow in case of an incident. So next we're talking about serverless. So serverless generally, when people hear about serverless, they think about servers or servers powering your application. But serverless is more than just computing. We have other serverless service options. We have data storage or database. S3 that I mentioned earlier is the serverless data storage. We have DynamoDB, which is a serverless database. And for integration also, we have API gateway. And serverless does not mean there's no server running. It just means that you are not maintaining or running any server from your end. The work of the maintaining and running is being left to AWS to do for you. And for that means it comes with some advantages. So we'll be talking about the advantages of the serverless option now. So for serverless, it is quite secure because you are not doing the running of the server, you are not maintaining the server, you are not doing any patching. So for example, if they need to patch any server for you, maybe Linux OS, you want to patch it. So if it's not done properly or there's an issue, it could lead to security breach for you. And also it's because you are not maintaining any server, it will increase the time to market for your product. So your developer will focus more on writing business logic for your code. And serverless computing option like Lambda, they scale easily. For example, Lambda could scale in seconds, maybe if there's an increase in traffic in your workload. And they are quite reliable and they are cost efficient also. And this cost efficiency now, that is when you are not, your computing option are not being called regularly. So normally, where you'll be making use of serverless computing option, for example, Lambda now is when your workload is not running every time. But once your workload will be running every time, so you need to review another option. So this is where EC2 comes in, or container. So next, I'll be talking about X-Ray, which is the AWS service that helps developer to analyze and monitor performance of workload. So X-Ray helps your team to debug your application, especially production application. We have different type of application, but it is quite efficient used for distributed application like microservices. So X-Ray is quite good for your application microservice. Like I mentioned earlier, there will be a lot of requests being made to your application. So X-Ray will monitor all the requests, and these requests are called trace. So it will monitor them, it will store them, and it can actually analyze this trace later. I'll be talking about the benefit of AWS X-Ray now. So X-Ray makes it easily for you to track your application. It gives you an insight into what is going on in your application, and also it improves performance. So because you could identify bottlenecks or where there's an issue, for example, if this part of your application, if there is high latency, because it will break every request down, every microservices, every request that's being made to every microservice, we break it down. So we know where there's a need for any improvement. Then it remove obstacle and save time and money also. So I will talk about how X-Ray work briefly. So for X-Ray, it collects traces. These traces are in form of request. For example, you could have a microservice architecture where users are making requests to API gateway. The API gateway will trigger the Lambda function, and the Lambda function will, any activity that's being performed in your code environment will be dumped in your maybe S3 bucket or DynamoDB. So the X-Ray will monitor all this interaction of the different components of your workload. So before I continue with the demo, I would love to know if there's any question at this moment. Is there any question at this moment before I continue? Okay. I guess that is no. So I will be sharing my screen now to show you a small demo where you can use X-Ray to monitor and debug your application. Okay. Please kindly confirm, or you can react with an emoji if you can see my screen. Can you see my screen now? Okay, thank you very much for the response. So for the demonstration, this is a simple demonstration. For this Lambda function, we are making use of Lambda function for this demonstration. So the code has been packaged as a zip file because there are a lot of modules it's making use of. So we package everything as a zip file. And also what this project is about is it's calling an external API. It's fetching random image of dogs from this external API. So, but this won't work because there's an issue with one of the package. So I will open this the URL of this function in the next tab for you to see. So I hope you can still see my screen. So this is the next tab now. It's saying internal server error. So now let's go to the X-Ray to check what's going on, what caused that error. Okay. Okay. Oh, I've been logged out, so I have to sign in again. So actually, this timing of logging out is another best practice, which is under security. So if someone have unauthorized access to your environment and it stayed there for long, it could cause a lot of hardware havoc. But because they will be logged out maybe after 1 hour or 2 hours, you can specify that. So there will be little to what they could do. And within that window, you could try and remove the access from that person. So I'm back here now. Okay. So here is our X-ray console. So this is a new interface for X-ray. There's an old interface where the X-ray it has a standalone console, but it has been integrated with CloudWatch now. The CloudWatch is also used for monitoring. So you have to scroll down here, you see the X-ray traces. So you click on traces to know the recent request that has been made. So you can select for the last 15 minutes, you can select for the last 30 minutes, 1 hour, just depending on the number of requests you want to see. So now let's go down. Okay, this is the map now showing the latency. Can you see now? It's showing the latency of each of the requests that has been called. So we have 4 traces for the last how many minutes? Okay, for the past 1 hour. So this is talking about the details of the request. We have the timestamp, it's showing the time when the request is being made, the response code. So because there was an internal server error, 500 is usually internal server error. It's telling us that there's problem with that request or there's something wrong in our internal application. So let's click on this request ID. Now, so you can see this is looking okay, but this is painted brown. So that means there's a problem here. So for us to now check where the problem is, let's click on this. So we have the overview. These are the details of the request being made also. So, but to check to debug for where the problem is exactly, we need to click on exceptions. So then we scroll down, you see the message. So I'm not sure if you could read this properly, I will read it out. So it's saying unable to import module lambda function, cannot import name, deprecated service name from bottle core. So this one is telling us that there is a problem with this package that we are trying to use. So with this X-ray now, it is very easy for us to know where there is an issue in our application. It is very easy to make improvements in our application. For example, I showed you the latency earlier. So this service is quite very useful to achieve high performance in the cloud and making use of AWS framework to achieve high performance in the cloud. And in conclusion, having a well-architected application in the cloud will determine how successful your business is. So it is quite important for you to have a well-architected workload, your workload being high performance. So with this, I would like to say you can reach out to our team. We have a dedicated team that has been trained and that are experienced in well-architected review. So they can help you to review your workload. So this will be the end of our webinar. So if there's any question, I'll be taking up. Thank you.
Well done, Oluwabamiche. That was a very insightful and lovely presentation. Please, if there are any questions, we would like to take them now. Okay, there's a question. Oluwabamiche, please, how do you balance performance optimization with cost considerations when designing AWS architectures?
Okay, so can you come again? How do I balance performance optimization and cost.
How do you balance performance optimization with cost considerations when designing AWS architectures?
Okay. So for most of the decision we'll be making while selecting architecture or following these best practices, and maybe the computing also will depend on your use case. So for your use case, you need to know the requirement of your workload. For you, if performance is very important, you have a critical mission business workload that you can't trade the performance for any other things. That means irrespective of the cost, you have to go for the high performance. And for example, where the workload is not, it's just the performance should just be just somewhere in the middle, but you are very concerned about cost. So that means you just have to balance it. So it depends on your use case. That will help you to decide on the trade-off to go with. You can trade performance for cost. You can trade reliability for performance also. So it depends on your use case. I hope I answered that.
Yes, that was a great answer. Another question is, can you explain how AWS well-architected design principles align with industry standards or framework for performance optimization?
Okay. Okay, like from our slide now, I mentioned earlier that the design principle are overview on step guidance to follow and philosophy. So, but to go deeply, this is where you make use of best practices. So, design principle is an overview. So, and for AWS, there are already established design principle already to follow for each pillar. So I hope that is clear.
Yes, Oluwabamiche, that is clear. Thank you very much for answering these questions and the insightful presentation. Please, to all our attendees, note that if you want to take the pressure off trying to achieve a well-working architectural environment and follow best practices with AWS, you can come to us at Secure Intelligence Limited. We are AWS partners and we can help get a well-architected framework review. Thank you for joining us today. You can reach out to us on any of our social media platforms, which will be showing on the next slide. On Instagram, we're at CIL_teams. On LinkedIn, we're at Secure Intelligence. On Twitter or X, we're at CIL_teams. And on Facebook, we're at CIL teams. It was nice having you here today. Please do also join us on our next webinar. Have a pleasant day ahead.